We are about to show the comprehensive traffic analytics dashboard by TraffiX, which revolutionized the traffic data collection, analysis, and insight to a whole new level. So, the TraffiX dashboard combines ground cameras and top view cameras to gather valuable and rich analytics for actionable intelligence. We see in the dashboard the total vehicles, license plates, pedestrians, and violations. On the Vehicle Analytics tab, we see each of the vehicles that crossed throughout the directions. When clicked, we can play the videos and the details of the vehicles along with the number plate image and number plate numbers. The type of the vehicle and which direction it is moving, the timestamp of the vehicle movement. We can search through date and time range specific, also the direction, filter by cameras, filter by lines, filter by vehicle types. There are 25 types of vehicles, and also optionally filter by number plate to find a specific vehicle. So within this range, let's search for a specific vehicle number. We see the vehicle appears. It's a car or SUV. Let's see where it was moving. Oh, the record we see with concrete evidence of the vehicle movements. We also see pedestrians here moving at which direction, and other vehicles that moves in specific direction from specific cameras. It has gathered all the vehicles that have crossed the Gulshan 1 intersection within this time range. The data is coming from the watchcam vehicle analytics, which is connected to the cameras across the intersection, and it gathers the real-time vehicle information along with the number plate and vehicle class. It is also capturing at what time the vehicle is crossing to capture the violation, and also if it is moving on appropriate direction or not, or either it is stopped or moving. So based on those informations collected on real time from the edge device, the data is aggregated for meaningful insights. Now here on the dashboard, those vehicles are becoming searchable, quantifiable, and insightful. If we filter by direction and particular type of vehicle, we will instantly get the quantity figure of how many CNG moved within that date and time range, and also get their detailed video records as well. Let's now search for violations. The most common is the red light violation. Let's search for it. We see within that time range the red light violation vehicles appear here. It's from the Niketan to South junction. We see after the red light those vehicles has been passed. Also the timestamp of the signal. Here we gonna get the pedestrian counts within a specific time range on each of the directions. We also get the flow rate, how many vehicles has been moved per minute. We can search for the count of the vehicle flow rate. We'll see more in the statistics. So on the statistics we see number of vehicles moving at each of the directions, which type of vehicles. If we switch to the monthly view, we see more greater picture. There are some data fields has low values, some have high values. For the pedestrians we also see similar charts. Within the weekly view we can also filter by directions and cameras to get specific picture of the pedestrian flow. From the chart we can easily find the flow rate, which is the vehicles per minute. On the monthly view we see the distribution of flow rate on each of the directions marked by legends. We also can get the distribution of vehicle types. We have 25 different categories of vehicles. For example, if we want to filter on a specific vehicle like car and SUV, we get the specific vehicles count distribution, and multiple vehicle distribution can we can easily choose within the time and date range to get exact analytics for various purposes. Moving forward, in the dashboard there are camera management. We have the WebRTC live camera view from the side cameras. The views are, we can choose the resolution of the view, low to medium to high. We can also select which camera to stream or not, and which camera we can see in live view. Due to using WebRTC protocol, we have ultra low latency streaming. We can also control the cameras from the dashboard, and if it has PTZ capabilities, we can control the PTZ capabilities as well. We can also see the online status of the cameras. Now here comes the signal status. The traffic signal, we can see the live traffic signal and the log of the signals, at what time which traffic signal was active, at which direction. The bird's eye view is the most interesting feature of this dashboard. We have a real-time overview of what's happening in the intersection. It has the flow ratio of each of the directions, and it changes for real time from the drone view. The drone view, it is a top view camera that detects the vehicle movements from different directions in real time, and also classify the vehicles including the pedestrians, and get very precise information about the direction of the vehicle, either it is moving or not, how much time it is taking to move from one intersection edge to another, and either it's stall or it's in a queue. So we're getting very rich insights and analytics from the top view, which is not possible from the ground cameras. So you combine the ground cameras and the top view camera to get a much more richer analytics for actionable insights. Here we see the line crossing data. We also see the movement direction statistics in chart views, monthly view, either east to west or any particular movement directions. On the crossing time, we can see the time is taken for average seconds. The vehicles has been taken to cross the intersection from which direction among the 12 directions. We can see the average crossing time from different dates within the date range, and also the statistics of number of crossings, from which we can get a detailed and precise overview within a custom range or weekly or monthly views. Then comes the region movement. The region movement is there are four regions that are actively controlled by the traffic signals. So on which region how many vehicles has was moving and how many vehicles are stationary, and the trend of their movement, from which we count the flow ratio on monthly or weekly basis. From the overview, we see the real picture of the intersection and get informed analytics for precise signal timing and enforcement management. The drone analytics provides a very rich information from the top view, which is almost impossible to get from ground cameras. So we leverage and combine both ground and top view cameras for getting the complete 360 picture of the intersection, for management, for enforcement, and for rich analytics and insights. Zooming in into the intersection, we can count the crossing time, the direction of the vehicles, the pedestrians, how the pedestrians are affecting the traffic flow, which type of vehicles are taking the most. So many insights that will come later that we can derive from the TraffiX dashboard. So we can see the traffic dashboard with lots of insights. Here we see the red light violation analysis, violation by type and the distribution, along with the comparative analysis by direction. You see the west direction has most of the violations rather than the north. Also we can toggle the chart, which is interactive, to see which type of vehicle is contributing to the violation at most. On the detailed data, we see the count of violations according to the directions. We also see key insights and recommendations. For this, like most frequent violator is the minibus, we see the problematic direction is the west direction, and also the peak violation time is 22 hours and within the date. So from the insight parameters, we can filter the date range, we can see the granularity. Like now we have change the granularity to daily level. So with this we can see within that 2 days that is selected, we can gain the insights and recommendations. So it's very useful for insights. The wrong direction analysis, we select the date range from 15th to 18th August, and the time granularity is daily. So within these we see from the 4 days time range, the 17th has lower wrong direction violations, and also the pie chart. The key insights are CNG Mishuk are the most violators, the south line to north, which has the most violation occurrences. If we change it to hourly settings, we will see the hourly distribution within that date range. This chart is interactive. We can toggle one or more vehicle types to get more directional insights. For example, we toggle the truck, and also we see the south to north has the most wrong direction patterns, and hour 8 has the peak hour for wrong directional vehicles. So this is very useful insights based on which we can export the data. We also can print it. Now moving forward to intersection crossing time, we can see there are car, van, bus, truck, different types of vehicles. Which takes the most? We see the pedestrian takes the most, which is normal because pedestrian takes the most time to cross the intersection. Also for the among the 12 directions average crossing time, we see east to north has the highest crossing time. So on the inside we see pedestrian takes about 160 seconds, awning tricycle, which is the rickshaw and that type of vehicles. The bottleneck route, we see west to east has the longest crossing time. So this is the bottleneck. And also the direction performance, east to west is the fastest, while east to north is the slowest, which have a difference of about 56.3 seconds. So the very beautiful and powerful insights that we can leverage on. Moving forward, if we change the granularity to daily level, we see the similar picture, and we see it in the on the daily basis. So next, peak directional flow rates. This is quite interesting because on the peak flow rate we see there are for each of the lines the flow rate of vehicles per minute. We see the line S has the highest flow rate, the slowest vehicle type is the awning tricycles. The impact of non-motorized vehicle is very important to analyze. We score the impact based on queue formation and flow rate. So if we compare the impact of non-motorized vehicle on flow rate and queue formation, we see between the hour 17 to 18 the impact is the highest. Also the number of vehicles moving compared to the motorized vehicles. Non-motorized vehicles account 6.4% of the total traffic. The dominant vehicle is rickshaw van. If we switch to hourly view, we see impact on queue formation is the highest for non-motorized vehicles. So they have the more impact on forming the queues. Moving forward to next, queue buildup analysis. For the green phase queue, we see uh, it has more queue length than the red or yellow phase, which is normal and expected. On the Sunday, average queue is highest. The critical signal phase has 23.3 vehicles, and hour 18 has the highest average queue length, and within that time range Sunday has the highest average queue. So based on this, we have some recommendation or consider special timing plan for that time. Next, we can see the peak directional flow rates. We have already seen this peak directional flow. Line S has the higher flow rate, which is southbound. Comparing to the 24-hour distribution hourly flow rate, we see at 8 a.m. and at 17 p.m. we see highest flow rate, 46 vehicles per minute at southbound line, found at 17.02 second. The hour 17 has the average flow of 10 vehicles per minute, and type 0 accounts, which is regular vehicle types. Switching to the our daily view, we see more complete picture among the date ranges. Pedestrian vehicle correlation, that's an interesting insights. The vehicle to pedestrian has we don't, although there is no direct correlation, but we try to map the average pedestrians and average flow rates. Among these, we see, if we switch to hourly view, or the daily view, weak positive correlation between pedestrian activity and vehicle flow, which suggests they appear independent. Peak pedestrian hour is hour 22, about 46 pedestrians, and pedestrian impact on flow rate is 25.1%. It reduces the pedestrian activity, the flow rate, by 25.1%. So that's very quantitative and actionable insights. The non-motorized vehicle impact we already have discussed. Rickshaw van has the higher density, most common non-motorized vehicle. Let's analyze the vehicle frequency by violation frequency by vehicle type. The violation frequency is which of the type of vehicle are more prone to violations. If you analyze hourly view, we see CNG Mishuk has more violation in tendency. Container trailer, minibus, bicycle. Some of the Common vehicle types, 87.6% CNG Mishuk vehicles are more committing violations more, and most violations occur at 7 a.m. That's interesting. On the daily view, you see Monday has more violations than Saturday and Sunday. Hour 16 has more violations. Minibus violations peak at 8 a.m. Auto rickshaw violations peak at 6 a.m. Monday has the most violations within that time range. This is not in general, so don't get confused. This analytics is within that time range, 16 to 18. And the violations over time,